The next type of transformation we're going to look at is what's called a reflection. If you typed into your calculator y equals x squared, you would get this parabola. If you then typed in y equals negative x squared, you will get this parabola, which is upside down. So you should see that this negative is making the graph turn upside down. Let's take a look at another one, see if it works the same way with absolute value. If you typed in y equals absolute value of x, you get this v. Y equals negative absolute value of x, you get this upside down v. So this negative right here is making the graph flip upside down. And the reason that happens is, look at the t-chart numbers. These are the t-chart numbers that go with my absolute value. These are the t-chart numbers that happen right here because this says take the absolute value of x, but then make it negative. So all of these numbers become negative. So notice in the chart here, the x values are the same as they were over here, but the y values have had their sign changed. That's the only thing we have to do with that negative that's in front there is change the sign on the y value. So if we have this graph y equals negative f of x, all that is the graph of y equals f of x reflected or flipped over the x-axis. And what you do arithmetically is you just keep the original x value, but you change the sign on the y value. And this is called a vertical flip because physically it is flipping upside down. It's going from top to bottom. That is a vertical flip. I call it a y thing because it's happening to the y value. So take a look at this. G of x equals negative f of x. I have just drawn this old graph here, f of x. And I want to then make a transformation where I have negative f of x. So this negative is outside the f of x. That tells me it's a y thing. So it's only the y value that gets changed. You might be thinking, well, how do I change that y value? Well, what you have to do is think about this. It says negative f of x. F of x is the same as y. So negative f of x is the same as negative y. Negative y is the same as negative 1 times y. So all you're doing is multiplying the y value by negative 1, which effectively just changes the signs on the y values. So that y value used to be 0, it's still going to be 0 because negative 1 times 0 stays 0. That y value used to be 1, it's now going to be negative 1. That y value, which was 0, stays. That y value used to be positive 1. When you change its sign, it becomes negative 1. And then connect the dots, and the red is your graph of your g of x. Notice this is a reflection over the x-axis. If you had a piece of tracing paper on your desk, you could trace this and flip it over the x-axis, and you would see it would land right on the red. Let's look at another graph. Let's take the graph of the cube root of x to see what happens with negative cube root of x. Well, remember, the cube root of x is one of those things you're supposed to memorize, and it's this little flat squiggly thing, but it might help us to know where it squiggles. So on our chart with the cube root, we were taking negative 1, 0, 1, and when you take the cube root of these numbers, they happen to stay the same. So negative 1, 0, 0, 1, 1, and as I said in a previous video, this is not a line. It's this squiggly that comes here through the origin and then bottoms out over here. I've gone a little too far, but it's hard for me to draw with this thing. To do this, instead of using my sloppy little graph, here's the nice graph, here's the points, I'm going to keep the x value and just change the signs on the y value. So this y value is 0, it stays 0. That y value is 1, it goes to negative 1. That y value here looks like it's 1.5, so it's going to go down here to negative 1.5 about. Over here, this y value is negative 1, it's going to flip up here to positive 1. Same thing over here, this is about negative 1.5, it's going to go up to about positive 1.5. And then connect this up, and you can see that this is just taking this and flipping it over the x-axis. Now there's also something called a horizontal reflection. If we typed into the graphing calculator the square root of x, this is what we get. If you type in the square root of negative x, this is what you get. Can you see what's happening here? This graph has been flipped over the y-axis. Another one like that, this is our x cubed graph. If I do on my calculator negative x in parentheses cubed, I get this graph here, which has been flipped over the y-axis. So the graph of y equals f of negative x is the graph of f of x reflected over the y-axis. In this case, we keep the y value and we change the sign on the x value. This is a horizontal flip. because the negative is inside with the x. So I think about it being an x thing because the negative is in with the x. So our rule on this is keep the y value but change the sign on the x value because it's an x thing. You see f of negative x, that tells you because the negative is with the x, it's an x thing. Therefore, I'm going to be doing something to the x value, nothing to the y value. So here's just that same funky little graph of my f of x. I look at this and I have to decide now that I know that there's two different kinds of flips, is this an x thing or a y thing? Well, where is your negative? Your negative is inside here, so it's an x thing. So we're going to make changes to the x value only. And how do we make changes to the x value? This says negative x. This is like negative 1 times x. And what that says is just change the sign on the x values. So this x value used to be negative 2. It now needs to be positive 2. This x value was 0, so it's still going to stay 0. This x value used to be 1. It's now going to be over here at negative 1. This x value used to be 4. It's over here at negative 4. Notice I'm keeping my y values the same. This point right here was the point 4, 1. When I've changed my x value, it now becomes negative 4, 1. I didn't change the y value at all. So now when I try to connect this up, this is what this looks like. This is taking my blue and flipping it over the y-axis. Take a piece of tracing paper, flip it over the y-axis, and you'll see it would land right on your red. Let's look at this same problem again from a different perspective. I know for some of you doing all that moving around of the points physically is hard to see. So let's look at this from a kind of a T-chart point of view. There are lots of points on this graph, but I'm going to take these that are enough to configure my graph. And I'm going to write those down in a T-chart form. So this is negative 2, 0. This point right here is 0, 1. Right here is 1, 0. And the one over that way is 4, 1. Now I'm going to make a new T-chart with this alteration I'm going to make. And that is the fact that all we're doing is changing the sign on the x value. So this used to be negative 2, it's now positive 2. Used to be 0, stays 0. Used to be positive 1, now it's negative 1. Used to be 4, so now it's negative 4. Those are the only changes I'm making. I'm changing the sign of each x value. I am not changing the corresponding y values. So this column is still 0, 1, 0, 1. And then let's actually plot those points and see where they are. 2, 0 is right here. 0, 1 stayed here. Negative 1, 0. And then negative 4, 1. And if I connect those dots, that's going to be the same graph we just saw a second ago doing it the other way. So maybe for some of you, converting things into the T-chart, looking at certain points, and then making the adjustments to the numbers in the T-chart would make this a little bit easier for you, especially as we get into problems where we need to make multiple changes.